Action potentials, action potentials, action potentials. You're about to watch a video about action potentials.
To begin, the dendrites on the motor neuron are stimulated by adrenaline in a vesicle from the interneuron. The adrenaline moves to the adrenaline-gated Na plus channels, causing Na plus to move through the channels towards the motor neuron. This is through the excitatory response.
The next step begins by an action potential propagating down the axon of the motor neuron. This begins with the resting state. The voltage-gated sodium channels are closed and the potassium channels are closed, keeping more potassium inside the cell and more sodium out, making the inside more negative. The next step is depolarization, where a stimulus opens some of the sodium channels, making the voltage inside more positive because of the inflow of sodium. Depolarization will occur till a threshold is reached. The next step is the rising phase, where even more depolarization will occur as voltage-gated sodium channels open. The inside will be the most positive at the peak of this point. The next phase is repolarization, or the falling phase, where sodium channels close and the voltage-gated potassium channels open, so potassium leaves the cell and the inside begins to become more negative. The next phase is hyperpolarization. The cell essentially returns to the resting state with the help of sodium-potassium pumps, putting more sodium out and more potassium in, allowing the cell to return to a more negative state.
The action potential then moves down towards the end of the motor neuron. This then triggers the voltage-gated calcium channels to open, and calcium flows into the motor neuron. This then leads to the vesicle moving towards the end of the motor neuron. Acetylcholine from the vesicle then activates the acetylcholine-gated channels, thus stimulating the muscles. Once this occurs, an action potential is then initiated in the muscle, causing the muscle to contract.
You just watched a video about action potentials, and we hope you enjoyed it.